Okay, Algebra 1. Last time we were together, we talked about the quadratic functions, which are parabolas in a graph. We talked about what it means to be in in standard form. So in standard form, that's what we see, we talked about intercept form, sorry. Intercept form, f of x is equal to a, x minus p, x minus q. Now, if this is intercept form, that's a big clue to me that I should be able to look at that thing and tell you the x-intercepts, p0 and q0. That's why we call it intercept form, because it identifies the intercepts, okay? Now, we've got another form that is vertex form, f of x equal a, x minus h squared plus k. So if you're paying attention, I should be able to look at that form and tell you the vertex. So let me see if I can graph this guy. I'm trying to capture this URL. So Alg1 vertex form. Let me just see if I can find it. So tiny URL, Alg1 vertex form. So tinyurl.com, Alg1 vertex form. Why am I not getting that to work? Let's try it again. tinyurl.com/Alg1 vertex form. There we go. So if I look at this, the graph in that first line, a x minus h squared plus k. So a right now is 0.2. So what does the a value do? So a is 1.8, a is 2, a is 3, okay? What happens when a goes negative? Okay, this is the same behavior as what we saw in intercept form. A is positive, graph goes up. A is negative, graph goes down, okay? Now, what about the k that's sitting out there by itself? What does the k do, okay? It looks like what I'm seeing the k do is moving the parabola up and down, okay? And then what about the h? It looks like the h moves the parabola left and right, okay? So if I look at this, this will help me then decode how to graph some of these things. So in vertex form, f of x is x minus h squared plus k. Let's look at what happens. F of x is equal to x squared. Okay, I know that starts at the origin. Over 1 up 1, because 1 squared is 1. Over 2 up 4, because 2 squared is 4. Over 3 up 9, because 3 squared is 9. And I get matching points. So I get this. The vertex is 0, 0. The axis of symmetry is the line x equals 0. Now, what happens if I look at this, this minus 2 means that that graph is going to move 2 to the right. The minus 4 means this graph is going to move down 4. So if I go 2 to the right and down 4, I'm starting right here. Now I can plug in points. Like what happens if you plug in a 2? You get 0 minus 4. That's where I'm at. So I'm at 2 minus 4. Plug in a 3. You get 1 minus 4 is negative 3, so this. Or I could just say, I know the pattern here. Over 1, up 1. Over 1, up 1. Over 2, up 4. Over 2, up 4. So I know the graph looks like this. Axis of symmetry is right here at x equal 2. The vertex is 2, negative 4. Okay. So the transformation, like I said, is just 2 to the right and 4 down. So if I look at this g of x that I just graphed, its vertex is what? 2, negative 4. Axis of symmetry was x equal 2. The x-intercepts. So I could see if when I went over 2 and up 4, those are my x-intercepts, 0, 0, and 4, 0. Anytime your x-intercept is 0, 0, it's also your y-intercept, because you find your y-intercept by setting x equal to 0. So there we go. Now, so the vertex form of a parabola. So you're going to have y, or f of x, equals a x minus h squared plus k. The vertex is hk. The axis of symmetry is the line x equal h. A is positive, parabola opens up. A is negative, parabola opens down. The larger the absolute value of a is, that makes this parabola thinner and thinner as we go. So let's graph some of these. So make sure it's in the right form, f of x equal x minus h squared plus k. So in this form, I've got f of x equals 2 x minus 1 squared plus 1. The vertex is going to be 1, 1, because it's x minus 1, so the vertex is at 1, 1. Now this parabola is going to open up because the number in front is positive. I know that this is my axis of symmetry right here, x equal 1. Now in order to graph the pattern for this guy, normally I would go over 1 from the vertex, I would go over 1, up 1. Here I'm going to go over 1, up 2. Over 1, up 2. Normally I would go over 2, up 4. You double that, you're going to go over 2 and up 8. So that puts me right here. And then a matching point, 1, 2, 1, 2, 1, 2, right there. And I see what's going on here. So the axis of symmetry is what? X equal 1. And I've plotted 2 points on one side, and I've got corresponding points on the other. What is the y-intercept? The y-intercept there is 0, 3. You find the y-intercept by setting x equal to 0. Okay. If I set x equal to 0 in this equation, I get 2 plus 1 is 3. The domain of every one of these guys is negative infinity to infinity. The range is just looking at your y values. The lowest y value is 1. So the y values go from 1 to infinity. Increasing, decreasing. If I start from left to right, this thing decreases from negative infinity until it gets to 1. So negative infinity to 1 is the decrease, which means the increase is going to be 1 to infinity. Graph negative 2 x plus 2 squared minus 1. So it's in vertex form, f of x equals negative 2 x plus 2 squared minus 1. The vertex is negative 2, negative 1. So negative 2, negative 1, there's my vertex. That means that automatically this is my axis of symmetry. X equals negative 2. This parabola will open down because of that negative number in front. The axis of symmetry is x equal negative 2. Now, when it comes to plotting points, normally the pattern is I go over 1, up 1. With that negative 2 in front, I'm going to go over 1, down 2. And then there's a matching point right here. Normally I would go over 2, up 4. Multiply that by negative 2, you're going to go over 2 and down 8. Okay, so over 2 and down 8 puts me right there. And then I get a matching point right there. So this gives me enough to graph the guy. Domain, negative infinity to infinity. The range are all the y values, negative infinity, and the highest y value is there at that vertex of -1. Graph the parabola y equals -1/2 x plus 3 squared. So f of x equals -1/2 x plus 3 squared plus 0. So the vertex is going to be -3, 0. So -3, 0 is right there. This thing open up or down, this guy's going to open down. Axis of symmetry is right here. Now, normally this guy, my pattern is over 1, up 1 because I'm squaring. This is going to be over 1, but down a half. So down a half, okay, down a half. Normally it would be over 2, up 4. Multiply that 4 by -1/2, it's going to be over 2, down 2, right? So right here, and then there's a matching point right there. And let's just go ahead and do it for granted. It normally be over 3, up 9. 9 times -1/2, down 4.5. So 4.5 puts me about right there. So I get a matching point right there. So I see something like this going on. The domain of that guy is -infinity to infinity. The range are all the y values from -infinity up to, I think it's 0 is the highest y value there. Yep. Okay. Now this one has 1x intercept. You know, the vertex lies on the x-axis. This guy, to find the vertex is -4, -5. So -4, -5. This guy's going to open up. Axis of symmetry, x equal -4. Okay, so if I want to find points that I plot, normally I go over 1, up 1, okay, because I'm squaring, but here, instead of going up 1, I'm going to go up 3. So over 1, up 3, that puts me at that point, and then I get a matching right there. So -3, -2, and what, -5, -2? Normally I go over 2, up 4. So in this one, I'm going to multiply by 3, so over 4, up 12. So, excuse me, over 2, no, normally it's over 2, up 4. Multiply by that 3, you get 12. So over 2, up 12 puts me right there. And then there'll be a matching point right there. So there we go. So that's what, -2, 7, and -6, 7. -2, 7, -6, 7. And the range of that is going to be -5 to infinity. So -5 to infinity is the range. And the domain, as always, for all of these is -infinity to infinity. Using vertex form to solve a word problem, okay? Deshaun and Chris are playing soccer. Chris takes a shot on goal. Deshaun is 3 feet in front of the goal. Okay. Can he reach the top of the 8-foot goal when standing directly beneath it? Can he block the shot from his current position without moving or without jumping? Okay, so I got to figure out what's going on here in this particular problem. So if I look at it, I've got a vertex, okay? So I just need to figure out the vertex is 1611, okay? And so I got to figure out where is the ball going to be at when he's 3 feet in front of the goal. So he's at 22, okay? So if I look at this, the formula here, f of x equals a, x minus h squared plus k. So hk, that's my vertex. So I get f of x equals a, x minus 16 squared plus 11. What else do I know? I know that when x is 2, the y value is 1.2. So 1.2 is equal to a, 2 minus 16 squared plus 11. So 1.2 equals a, and this is 14 squared plus 11. So what do I get here? So I get minus 9.8 equals, and that's 196 a. So a is negative 9.8 over 196. So a is negative 0.05. So a is negative 0.05. So this formula is f of x equals negative 0.05 x minus 16 squared plus 11. So I need to figure out how high the ball is at 22 feet. Okay, so so at 22 feet, I can just plug in a 22 into this problem. So f of x, or actually I'm plugging in 22, is equal to negative 0.05, 22 minus 16 squared plus 11. So 22 minus 16, that's 6 squared, so that's 36. So negative 0.05 times 36 plus 11. So plus 11, 9.2. 9.2. So that tells me right here at this spot, the ball is 9.2, and this is feet. So if the ball is 9.2 feet, and our guy, so he can reach the top of the 8-foot goal, so the 8-foot goal is right here, then can he block the shot standing where he is? Well, if he can only reach up 8 feet, and at that moment the ball is 9.2 feet, it goes over his head, okay? So can he do it without moving or jumping? The answer is no, okay? The ball is 9.2 feet at that point. So again, all we did here was they gave me a vertex. Shock of all shock, I use vertex form, okay? Because if they give me a vertex, I can use vertex form. I have this extra point, which allows me to solve for a. Now, I knew a was going to be negative because this is a parabola that opens down. So I knew it had to be a negative value, and that was borne out in doing the solution to the problem, okay? That leads you up into homework for this section.